How to visualize superposition, multiple states at once. Imagine watching a tiny particle dance in a fog of possibilities, not just in one spot but in many places at the same time. That's what superposition is all about in quantum physics. It's the idea that a quantum system, like a qubit, can be in multiple states until we look at it. But how do we actually see this strange behavior? That's what we're here to explore. One of the most popular ways to picture a single quantum bit is with something called the Bloch sphere. Think of it as a globe where the North Pole represents the state 0, and the South Pole is the state 1. Any point on the surface of this sphere shows a mix of 0 and 1, with specific probabilities and phases. So instead of being just 0 or 1, the qubit can be anywhere on the surface, showing how it exists in many states at once. The closer a point is to the poles, the more it leans toward one of those classical states. The middle of the sphere shows a perfect balance, a true superposition. But the Bloch sphere is just the start. For more complex situations, scientists use colorful probability clouds or landscapes. These images show where a particle might be found if we measure it. The brighter or more intense the color, the higher the chance of finding the particle there. These visuals help us understand that superposition isn't about a particle being in one place or another, but about a range of possibilities that overlap. When dealing with multiple qubits, things get more complicated because the number of possible states grows exponentially. To handle this, researchers use special visual tools like the Q-sphere. It maps multi-qubit states onto a sphere, where colors and sizes encode the likelihood and phase of each state. Sometimes, entanglement, the mysterious link between particles, is shown with lines or blinking blobs connecting the particles, indicating how their states are intertwined. Scientists also use real-world experiments to visualize superposition. For example, by studying electrons in materials like graphene, they can reconstruct the wavefunction, revealing how electrons occupy multiple atomic sites at once. These images connect the math of quantum mechanics to what we can observe in labs. Iconic experiments like the double slit show superposition in action. When particles pass through two slits without being observed, they create interference patterns, proving they act like waves and pass through both slits at once. The famous Schrodinger's cat thought experiment takes this idea further, imagining a cat that is both alive and dead until someone checks. It's a way to understand how superposition challenges our everyday ideas of reality. To sum up, visualizing superposition involves using geometric models like the Bloch sphere for simple systems, colorful probability maps for more complex ones, and real-world images from experiments. These tools turn the abstract math into pictures we can see and understand. They help us grasp how quantum particles can be in many states at once, which is the foundation of quantum technology and future innovations.